Do It. Innovation and Invention, Part 1. Inventors and innovators solve problems in new and creative ways. First, however, they observe the world around them and ask questions. Materials. All of your senses. One object, or an area that includes a group of objects. Timer. Pencil. 2 sheets of paper. Friend. Optional. Procedure. By yourself or with a friend, observe all you can about an object or an area that includes a group of objects, such as a rose bush or a playground, a cat or a parking lot, for a full 5 minutes. Make a list of everything you observe. If you can, and it is safe, use all 5 of your senses to increase your range of observations. When 5 minutes are up, read your list. If you are with a friend, compare your lists. How many of the objects on your lists did you notice for the first time? How many of the objects you observed raise questions in your mind? For instance, if you spent your time looking at a rose bush, you may have noticed that some of the blossoms were drooping. Did you wonder why? Put a check mark next to the observations that raised questions for you. Then, write down the questions on a separate sheet of paper. Save the list for the next activity. Do It. Innovation and Invention, Part 2. After Franklin made observations, he often conducted experiments to find out why certain of the things he noticed happened. Sometimes his experiments were simple activities he could do in his backyard, such as the experiment with the cloth and the snow, page 8. But sometimes Franklin's experiments required research and hard work. For example, when Ben was Postmaster General of the American colonies, he observed that the mail sent by ship from America to England arrived in good time. But the mail sent by ship from England to America took 2 weeks longer to arrive. This happened over and over again. The pattern made Ben wonder why. He had some ideas. Maybe the English sailors were lazy. Maybe the American ships were better built. But he needed an answer. Ben Franklin asked his question of a Nantucket sea captain, Timothy Folger. Folger explained to Ben that a strong current in the Atlantic Ocean helped to speed American ships eastward toward England. But on the return trip west, the current slowed ships down. Ben worked with Folger to determine just where the current ran. He watched the progress of ships to see whether his calculations were correct. Finally, he drew maps of the ocean that showed the location of the current. All of this information helped Ben speed up the mail delivery. He told the captains of his mail ships to take advantage of the rapid current on the way to England and to avoid the current when returning to America. Ben named the current the Gulf Stream because it originated in the Gulf of Mexico. His observations have been important to shipping navigation and weather observation for over 200 years. Ben had a specific question to answer. Why does mail from England to America arrive 2 weeks late? Instead of shrugging his shoulders, he looked for an answer. He had some ideas, but he did not assume his ideas were correct. Instead, Ben worked hard to uncover the possibilities, tested his calculations or results of using mathematical processes, and charted his final answers. Materials. The list of questions from the activity Innovation and Invention Part 1, pencil, sheet of paper. Procedure. Number 1. Return to your list of questions. Pick one that interests you. Then, think about what the answer to the question might be. Write down all the possible answers you can imagine. For instance, if your question is, why are the rose blossoms drooping? You might write down several possible answers. Because the rose bush doesn't get enough water. Because the bush is getting too much sun. Because the dog has dug up the soil around the bush. All of these answers may be correct, or only one may be correct, or there may be another answer that you haven't thought of yet. You can eliminate some possible answers right away. For example, you can check whether the soil around the rosebush has been dug up. If it hasn't, you can eliminate the dog as the culprit. But how can you find out what the problem really is? The answer is, you experiment. Number 2, pick one possible answer to your question. An educated guess about the outcome of an experiment is called a hypothesis. In the case of the rosebush, you might guess, the bush is not getting enough water. Number 3, test that one possible answer to your question. By testing only one possible answer at a time, you can determine which answer is correct. In the case of the rosebush, you might try giving the bush plenty of water for a week. Number 4, analyze your results. In this example, you would pay attention to how the rosebush responds to the extra water. If it does not perk up, it's time to pick another possible answer and test that one. If the bush stops drooping, it may be because of the water, but it could be caused by something else. When you test a hypothesis through experimentation, you end up making conclusions, such as the conclusion that lack of water probably made the rose blossoms droop. But it's not always quite this simple. Sometimes more than one factor may be at work. For example, the rosebush may also have been getting more sun while you were giving it more water. You know now that this system of experimentation is called the scientific method. Ben Franklin was a doer. He always had ideas about how to use his discoveries, and many of his most useful inventions and innovations came out of his own experiments. Based on his cloth and snow experiment, Ben found it was a good idea to wear light-colored clothes in summer. Through his discoveries and experiments with the Gulf Stream, Ben was able to speed up mail delivery. Do it. Innovation and Invention, Part 3. You've already made observations, developed some hypotheses to explain your observations, and conducted experiments to find out which, if any, of your hypotheses were correct. Now, what can you do with this information? It's time to take action. Materials. The test results of your experiments in Innovation and Invention Part 2. Pencil, sheet of paper. Procedure. Number 1. Look at the results of your experiments. What have you learned? Number 2. Based on what you know now, list your possibilities for action. For example, if you discover that the rose blossoms are drooping because the bush is getting too much sun, you might want to move the bush or build a special roof over the bush, called an arbor, that will let just enough sun through. You might even decide to breed a more sun-resistant strain of rosebush. Moving the bush is a simple, practical solution. Building your own version of an arbor is an innovative idea. A whole new kind of rosebush is an invention. Number 3. Pick one possibility on your list to act on. For example, build an arbor to let just enough sun through. Number 4. Draw up a plan for taking action. Remember, you don't have to build or make something to take action to solve a problem. Your plan may involve talking with people, reorganizing a closet, or even developing a better way to keep your sister out of your room. You will need to start by making a list of the materials you will need. In the case of the arbor, you'll need wood, nails, a hammer, measuring tape, and so on. You may need to add adult helper to your list if you are working with sharp objects or electricity. You may also need help to develop a workable design. Now list the steps you will take as you complete your plan. In the case of the arbor, you'll probably start with find the money to buy the materials, and so on. Number 5, take action. Go ahead and do what you plan to do. Don't be discouraged if your first attempt at invention or problem solving is not completely successful. Many of the world's greatest inventors, including Ben Franklin, had to experiment with many solutions before they succeeded in solving a problem. Trying, troubleshooting, or problem solving, and then trying again is an important part of innovating or inventing.